its common multiple of 10 and 12 is equal to 60 times 8, and I will give you 480. So 480 is the 8th common multiple of 10 and 12. Now, having said this, we go very quickly to the next subtopic under this very section. We're taking highest common factor. Now, we've talked about common factors, how you can get the common factors of two numbers. Now, let us look at it again the second time. If we have the numbers 12 and 18, a short while ago we got the common factors of these two numbers. For 12, we got 1, 2, 3, 4, 6, and 12. These are the factors of 12 we got. And for 18, we got 1, 2, 3, 6, 9, and 18. These are the factors of 18 that we got. Then the common factors amongst these 12 and 18, or the common factors between these 12 and 18, the common factors are 1, 2, 3, and 6. Now look at the common factors. Out of these common factors, 6 is the highest of the common factors we have here. So what it means is that 6 is the highest common factor of 12 and 18. So this is just one of the ways by which you can find the highest common factor of two numbers. You get the factors, you now get the common factor, you now get the highest common factor from the common factors. Just the highest of the common factors is the highest common factor. Now, we also have other methods by which we can use, by which we can calculate the highest common factor of numbers. Now, we're going to take the example 1, calculate the H.C.F, that is the highest common factor of 16, 24, and 36. 16, 24, 36. Okay. Now, the method I want us to use here is the method of prime factors. We're going to start with the smallest prime number that can divide all of these numbers, whose highest common factor we are looking for. Remember, in lowest common multiple, what we did was that we used the smallest prime number that can divide at least one of the numbers in question, at least one. Even if it cannot divide all of them, but it can divide one, we can use it. But here, in this H.C.F, the prime factor we're going to use here must be a factor of all of them. It must be able to divide all of them. So we have to start with the smallest prime number that can divide all of them. That's the one that's a prime factor to all. And from what I can see here, 2 is a common prime factor to all of them. So 2 can divide 16, 2 can divide 24, 2 can divide 36, so we use 2. 2 divide 16 is going to give us 8, 2 divide 24 is 12, 2 divide 36 is 18. We're still going to continue like that. We're going to use only the prime number that can divide all of them, the smallest prime number that can divide all of them. Now, 2 can still divide all, so we use it. 2 divide 8 is 4, 2 divide 12 is 6, 2 divide 18 is 9. We're still going to continue like that. Now, 2 can no longer divide all of them. Here, 2 can divide 4, can divide 6, but it can't divide 9. If we try the next prime number 3 to see, well, 3 can not divide 4, it can divide 6, it can divide 9, but it can't divide 4, so 3 will work. If we try the next prime number 5, it can't even divide anything. If we try the next prime number 7, it can't divide. If we try the next prime number 11 now. So you see now that we have exceeded all of the prime numbers that can possibly divide here. So no prime number again can divide all of these numbers without a remainder. So the only prime numbers that can divide them, the only ones we got now are these. So the H.C.F is just a multiplication of these common prime factors to all of the numbers. 2 times 2 equal to 4. The H.C.F of 16, 24, and 36